this one example 1.5, and we're going to prove the following. Tan to the 4 theta, even scarier than the cotangent cubed one, minus secant to the 4 theta equals, how hard do you want me to make this one? Medium? Really hard? Really hard? Okay. We're going to make this one equal to negative sine squared theta minus 1 over cos squared theta. Okay. What strategy this one is getting to in your strategies? First of all, we have tan and we have secant. So part of your mind should go to, well, I know that there's a relationship between tangent and secant if they're squared. The strategy that this one is getting at, and is hoping that you recognize, is a factoring strategy. Because when you have a difference of squares, you can factor it. So do you recognize that on the left side you have a difference, because there's a minus sign in between them, and both tan to the 4 and secant to the 4 are perfect squares. So you can factor this. Again, choosing a different strategy and not recognizing the factoring might cause you to have a really, really long proof. And again, if you change this one to sine and cos at the beginning, you might find out that you have a really, really long proof that you have to try and solve. And even halfway through that proof, you would still have to use this factoring strategy that we're going to do now, so it makes sense to do it at the beginning. As far as factoring, we're going to get tan squared and tan squared, secant squared and secant squared. One of them will be plus, one of them will be minus. Now, of those two, if you think about our formula, which says tan squared theta plus 1 equals secant squared theta, could you rearrange that formula to get either tan squared plus secant squared or tan squared minus secant squared? You can only get one of those two. Can you see that you can get tan squared minus secant squared? What would it equal if you did that? Negative 1. So you can see if you move the secant square over to this side and move the 1 over to that side, you would get tan squared minus secant squared, and it would equal minus 1. So now we can change this to just minus 1. That makes our life a lot easier. Because this is the same as negative tan squared theta minus secant squared theta. So now we've simplified it, at least we're down to squares at this point. We already know that this minus tan squared minus secant squared, we cannot rearrange tan squared plus 1 equals secant squared to look like that. So at this point, being aware of the other side, I have this side with sine and cos, this side with tan and secant. Now it would make sense to change everything to sine and cos. If we did that, tan squared is negative sine squared over cos squared minus 1 over cos squared. Do we have a common denominator? Yes. So put it as a single fraction, and then let's see if we need to do anything else. Hey, we're done. Cute.